His presentation is entitled Process to Text, a framework for the description of processes in natural language. For a small introduction about this field, processes constitute a useful way of representing and structuring the activities and resources involved in organization information systems. Daily, more even data is being produced and recording, and process mining goal is to exploit this data by automatically discovering the underlying process model to stack valuable information, process-related information in a meaningful way. In order to represent these process models, a graphical representation is mainly used, but Yago he's proposing to use natural language generation in order to generate natural language descriptions of qualitative and quantitative information about these processes. So this is the main subject of his PhD. His supervisor are Alberto Bugarin Diz and Manuel Lama Penin. So it's my pleasure to give him now the time to present during 20 minutes, please.
Okay, thank you. So first I'll start sharing my screen. So I hope everyone can correctly see my screen.
Yes.
Yep. Okay, cool. So as Juan Antonio just said, my name is Yago Fontenla Seco, and I'm a PhD student here at CITIUS. And today, in this doctoral meeting, I'm going to present the current state of my thesis research called Process to Text, a framework for the description of processes in natural language. So first, I'll start with a brief introduction, or not so brief, of what processes and process mining is. So, as Juan Antonio said, processes constitute a useful way of representing and structuring the activities and resources that take place in organization information systems from almost any domain. The behavior of these processes is usually represented as process models that represent in a graphical way the activities as nodes that take place in a process, as well as the dependencies as arcs between them. All the relevant properties of the process tend to be included in the model, such as frequency or temporal properties. When a process is executed in real life, its behavior is recorded in what are called event logs. Event logs contain information about the executed activities of the process. Being an activity, each well-defined step in a process, an event represents the execution of an activity in a particular instant. So events can have, apart from these attributes, additional attributes such as associated resources, duration, and more. Then a trace is an ordered list of events, and it represents the sequence of events a case follows. So then we can say that a case represents each particular execution of a process. As events, case also have attributes, and the mandatory attributes for a case are its corresponding trace and identifier, but other attributes may be present, such as its throughput time, or as we can see here, the admittance origin of some patient in the cardiology service of a hospital and its age. As more event data is being produced, it is necessary to provide these organizations with tools capable of processing this data. This is the goal of process mining techniques that, through applying discovery algorithms, the underlying process model is discovered from an event log. So on one hand, we part from process model analysis techniques that are model-centric disciplines that put all their emphasis on theoretic process models without giving attention to execution data. On the other hand, data mining techniques focus completely on the data without paying attention to the model. So we can say that process mining serves as a bridge between these two techniques, between business process model analysis and data mining techniques, which its goal is to exploit recorded event data by automatically discovering the underlying process model to extract with it valuable process information. We can identify three types of process mining. As I've already said, discovery algorithms take an event log and produce a model explaining its behavior. Once the process is discovered, it can be compared with its corresponding event log. Conformance checking is used to check if reality, as recorded in the log, conforms to the model and vice versa. So it can be used, for example, to detect and explain deviations in the behavior from the model. And finally, the idea is to improve an existing process model using the information recorded in the log. So in this thesis, the attention is focused mainly on conformance, as this type of process mining is which allows to users to understand what is really happening within a process. The key element in conformance checking is the replay of the event log over the discovered model. This is done by executing the events of each trace in the log over the model in the order indicated from start to finish. This allows to extend the model with frequencies and temporal information. Then to allow to find, for example, execution problems, missing activities, bottlenecks, and errors. So apart from extending the process model, additional analytics which summarize relevant information about a process, quantitative relevant information mostly, such as frequent or infrequent patterns, can be computed. These analytics are usually communicated to users through visual analytics. Here we can see a chart that illustrates the timing of the execution and relation between activities of a process during its time span. But as we can see, in real-life scenarios, both process models and its related analytics are very complex, with a high number of relationships between activities. Also, the amount of information that can be added to enhance this model is very high. So it is quite difficult for users to understand this information, as deep knowledge of process modeling and analytics is required. So to illustrate further the problem, I'll propose a real-life case study in the health domain. Here we have the theoretic process related to the patient's management in the valvulopathy unit of the cardiology department of the university here from the Hospital of Santiago de Compostela. This process represents the medical examinations, tests, and events that a patient undergoes in the units in order to understand its state and to decide its treatment. However, here we can see that the theoretic process model is not real, and this is the real process model that has been discovered from an event log with data on 588 patients. It is a very complex model, since, as it can be understood, patient's management depends on their pathological state, which means that the frequency of each trace and each path is very low. So medical experts show real interest in applying process mining techniques to this process because it allows them to extract knowledge like relationships between patient attributes, relationships and delays between activities, or to understand which different paths in the process patients with different attributes follow. However, understanding this information is difficult. For example, one of the questions experts posed was, which is the difference in the delay between the medical surgical session and the surgery of patients from ambulatory admittance and emergency admittance? As you can see, it is not trivial to extract this knowledge from the process model, nor from the event log. So because the questions users look answers for are quite complex. So how can information then be conveyed to users in an understandable way? Natural language generation and linguistic descriptions of data fields provide methods for generating insights on data through natural language texts that summarize the most characteristic aspects of some data. This information can be easily consumed by users, as natural way is our inherent way of communication, and because through the use of uncertain terms, this communication is very effective. Also, in this sense, some researchers suggests that in some domains, experts can take better decisions based on textual descriptions than on graphical displays. Therefore, natural language seems like a good approach to enable or at least enhance the understanding of processes and its related analytics. The generation of natural language text from data originated in the natural language field, particularly in the data-to-text research community. By using knowledge of language and the domain of application, data-to-text systems produce automatically natural language text from non-linguistic input data, such as sensor data or event logs. The basic pipeline consists in an event data interpretation stage, which uses domain knowledge to infer relationships or patterns between events and produce according messages. Next, a document planning stage decides which messages should be conveyed to the users, and a final microplanning and realization stage, which converts these messages into natural language texts. However, in the process field, these kind of systems have only been used to describe process model without taking in account any execution data. On the other hand, coming from the fuzzy logic realm, linguistic summaries or descriptions of data have been applied in multiple domains. These descriptions of data are fuzzy quantified statements that express the number of elements of a dataset that fulfill certain property. These statements follow formal structures or templates that are referred to as protoforms, and type 1 and type 2 have been the most used ones in the literature, where a referential X represents a dataset of objects for which certain property holds, for example, the set of cases from an event log. A summarizer A is used to indicate some property of the referential of interest, for example, short waiting time. And a fuzzy quantifier Q is used to express the quantity of data from the referential which fulfills the property or properties indicated by the summarizer. A qualifier B can also be added to the description to better define the scope of the sentence, as it defines a subset of the referential. In this case, it would be the emergency admittance cases. Then, a degree of truth is used to relate the validity of this proposed protoform. So, instancing a protoform involves assigning values to its elements and computing its truth degree, which confronts the proposed summary and the dataset in order to assess if the summary captures correctly the properties of the referential present in the dataset. However, these linguistic summarization techniques have only been used on process data based on data mining techniques, without paying attention to the underlying process model. So this makes evident the need to propose a new series of protoforms which do take in account both aspects of a process and that are based on process mining techniques. So as we just saw, natural language makes for a good way of conveying information, but we can see there's a lack of attention to both process perspectives in this field. So we propose using process mining discovery algorithms and based on the data-to-text architecture and on a new series of fuzzy temporal protoforms, the process-to-text framework. So following a general model that includes both quantitative and qualitative information from processes, and combined with the use of fuzzy linguistic descriptions of data, this model allows for modeling and managing the inherent imprecision of linguistic terms, which is very useful when summarizing data such as frequencies and temporal. So the main idea is that with an event log as an input, its underlying process model is discovered and extended with frequency and temporal information, which then is summarized with the use of linguistic descriptions of data in the framework of a data-to-text system. These descriptions are then finally realized into natural language text following a hybrid template-based approach. So to better follow the explanation of the pipeline, I'll be using the example question posed before. So remember, which is the difference in the delay between the medical surgical session and the surgery of patients from ambulatory admittance and emergency admittance? To answer this question, we first need to know the delay between activities, medical surgical session, and surgery for each patient, as well as the type of admittance this patient had, to then be able to compute the quantified statements that correctly summarize the data. To clarify, in the original event log, each case corresponds to one patient. So when we talk about patients, it's the same as talking about cases. And patient attributes will be the same as case attributes. So then, the first step in the data interpretation stage is the discovery of the process model from the original event log with the use of a mining algorithm. Once this is done, the event log is replayed then over the extracted process model, extending the model with frequency and temporal information. So now we have a dataset in which, among other attributes such as case ID, sequence of activities followed, this is the trace, and more, we have the origin and the waiting time between the medical surgical session of a patient and its surgery, as this is precisely the frequency and temporal information replaying the log over the model allows us to extract. So in the next stage, statistics about the attributes are summarized into indicators in each of the corresponding process analysis modules. Indicators such as average, duration, and frequency, maximum and minimum values of frequency, changes or deviations, etc. are computed. These statistics will be later used in the protoform generation stage to decide which information should be conveyed to users. For example, for the proposed question here, two groups of patients are compared. So statistical testing can be used to decide whether the waiting times between the two groups are different, so this information is relevant and must be shown to users. Once it has been decided that some information must be conveyed to the users, the next stage is to generate the corresponding protoforms relating to said information. As we can see, the question we are trying to answer is a question comparing two groups of patients. However, due to the lack of expressiveness and limited semantics of type 1 and type 2 protoforms, this is not possible in a direct way. This is why we propose the use of composite protoforms formed by two protoforms which contrast each other through a semantic relation, that are, in this case, able to put in relevance the difference between attributes or that may be causing the variance over other attributes. In the literature, this strength is usually computed or defined manually, but as I just said, we, in the previous slide, we do this with statistical testing to decide whether these two protoforms must be confronted to each other. So now a template is filled with the elements of the computed protoforms, and with the aid of the simple NLG realization engine, the composite protoform that was just defined is realized into natural language text. So from the initial question the medical experts proposed, a natural language text is generated through our framework from process data. So the final result, to answer the question posed, would be: most patients with ambulatory admittance have an average waiting time between their medical surgical session and surgery. However, several patients with emergency admittance had a waiting time shorter than expected. So here I have presented the process to text framework which integrates the process mining, natural language generation, and new fuzzy linguistic protoforms for the automatic generation of textual descriptive explanations of processes. These descriptions include both quantitative and qualitative information related to the process execution, extracted through process mining techniques. And a real use case in the medical domain has been presented, showing with an example the potential of process-to-text for providing, in this case, natural language explanations addressed to cardiology specialists about consultations and interventions of patients in valvulopathy units. So this was all. Thank you very much for your attention. I'm completely open to any question.
Thank you very much, Yago. So if someone has a question, please raise your hand in Teams and I will give you the lead. Okay, Alejandro Catalá, could you please go ahead?
Hi, morning, Alejandro.
Okay, thank you, Yago, for your presentation. Well, I have a question or a comment because you nicely show that the kind of models or the graphical models are very complex, right? And I was wondering whether these sort of models or visualizations are still to be consumed by the target users. I mean, in the end, the idea is not just to provide the description in natural language that corresponds to the process, but also provide the visual representation, right?
Yes, sure.
Okay. In this sense, I wonder whether you plan to, or you have considered. Okay, it's clear that it's very. We agree that it's very complex, the original or the whole model, but as the natural language description is already giving a simplified, let's say, because it's not capturing everything, right? It's capturing the most important things. Then I wonder whether you are considering also to provide a version or visual version of the original process model that is consistent with the natural language description provided as well. And then here, I guess the challenge would be to make sure that the obtained visual or process model is also consistent with not only with the original one, but also with the natural language description. So it's just a comment in case.
Yes, sure. So
I believe
actually,
it would be very useful. I don't know how you see it.
Yeah, sure. What I was saying is that actually the techniques for extracting as I think I have here, a simplified. So this is the original model, as you said, but in previous slides, this is the same process, but a simplified version. So actually, the same techniques that are used to simplify the model are the same techniques that are used to generate the text, because the underlying information is the same. We just have the event log and the process model. So yes, we are actually under a validation process to evaluate whether textual summaries, visualization techniques, or a combination of both is the best way for users to understand this information. So if the combination results to be the best way, that probably I think it could be, because once you read the description, normally an image is easier to understand. So yes, as the underlying information, as I said, is the same, the information presented in both ways would be consistent and would make it easier to the users to understand that this information.
Yeah, thank you.
You're welcome.
And congratulations for your
ongoing
work.
Yes, ongoing.
Thank you very much, Alejandro. So there is some more questions. Yes, I think Andrea Cascallar Fuentes, please.
Hi, thank you for your presentation, Yago. I think it was very interesting for me. I have a question regarding to the composite protoforms you explained. I see they are linked by a semantic relationship. For example, however, you put in the example. My question is, how do you calculate the strength of that relation between the protoforms?
Okay, first, thank you for your question. It was very nice. So I think I have one slide. The slide you said it was, I think, no, this one. Well, so in the literature, in the fuzzy logic literature, the strength of the relationship is normally defined manually using expert knowledge by assigning values to pairs of linguistic variables. For example, if you want a composite protoform that compares waiting time, you can define a matrix and you assign values for example, short waiting time versus average waiting time. So if the composite protoform aims to confront, as these values are completely opposite from one another, you'll give them a value of 1, for example, that the maximum value of a strength in a relationship like, however, that is opposing one term to another. However, as in this case, we follow a more data-to-text centric approach, we use domain information directly. And as I said, and with talking through with the experts and all that, we thought that the better way to decide when to confront two protoforms was with the use of statistical testing. So we compare the two groups of, in this case, of patients, and compare if their waiting times are statistically different. So if this is the case, we then generate the individual protoforms from one another, and then we compose those protoforms to convey to the users that indeed the waiting times between those different patients groups are different. I hope I answered your question.
Yeah, thank you. It was very, very interesting, and congratulations for your presentation. It was very nice.
Thank you, Andrea.
Thank you.
Thank you very much, Andrea. So are there more questions? No, for the moment it seems that there are no more questions. So perhaps I can make you one question, Yago.
Sure.
Thank you very much for your presentation, and I agree with colleagues that it was very interesting. You managed to show us the difficulty of this subject. There is Alejandro. Okay, after my question, I give you the turn.
Yeah, I do have another question. Maybe.
Okay, go ahead, and I give my question later.
No, maybe. Thinking about what you have presented, and knowing that other peers are also working or collaborating with you and your supervisors, I wonder whether, looking at the protoforms, I wonder, maybe this is not a question only for you, but also for your supervisors. And I wonder, right now, if I understood well, you define the protoforms and then you define some sort of templates for natural language, right? Probably this is, let's say, the right way to do it. And this is also, we can say that they are thought for the case study that you have in your hands, right?
Mm-hmm.
So I wonder whether it would be possible in the future, based or depending of the different case studies, to be able to define automatically the templates.
Mm-hmm.
No? So trying to, depending on the structure, perhaps with if we got enough knowledge about how everything works and how generation could be, then in the future, or in the very future, it would be possible to actually the system to define this automatically. So it's just a thought.
Okay, so actually, I just used the case study for helping follow the presentation. But as I said, in this case, we're interested in waiting time as an element of description, but any attributes can be described. And I didn't say it because time's limited, but these attributes are, if you see an event log, this is similar to when you simply are presented with a data mining problem. And you know that in any data mining, machine learning problem, you can perform what is known as feature engineering. So this is a general framework that, in any problem, there is the need to have some domain knowledge and always to work with domain experts, because feature engineering is not done until what I know, is not done all by itself. So we define a general framework that, with the need some domain knowledge, you can define that any attribute you're interested in, these attributes are the ones that are generated into summaries in a general way. And then in the last step, again, domain knowledge is needed, because you don't want to generate the text in the same way when you are in a process, I don't know, any organization process like an industry, than when you're talking about patients or when you're talking about health. So the core of the framework is a general approach, where with process mining techniques I want to put in relevance that what we do is compute like these attributes, these frequency and temporal relations that are until now neglected in the literature. And as these attributes are computed, any other attributes for, in this case, patients, but if it was a machinery industry, you could have attributes about the color of the car paint or whatever, and generates these summaries relating all these attributes. So I don't know if these templates or this last generation step that is so like domain dependent could be made automatically right now. But it is a nice question, and it would be good and nice, obviously, to be able to automate every step of the process. But as in any other related AI fields, until now, some domain knowledge and domain integration is still needed.
Thank you, Yago. Very clear and very nice.
Thank you, Alejandro.
Research.
Can I make an additional comment, please?
Sure.
Yes, in the case of processes and process mining is a particular case, because usually in natural language description you have a domain which is a particular domain. But in this case, most of domains in process mining that have processes have the same elements. That is, a process is the same. The elements of a process are the same in health, in industry, in e-learning, etc. Then we can have model-independent and a model-dependent knowledge. That is, we have an independent and another dependent model. The dependent model is related with the attributes, with the particular attributes of the domain, and the independent model are related with the control flow, with the resources, etc., etc. Then we are thinking, but as a future work, in modeling the dependent and independent model with ontologies. And we can analyze the ontologies, the graph of the ontologies, and automatically generate templates. This is, in this moment, is an abstract idea, but this is the path we are thinking follow.
Yeah, thank you. I think it's very interesting, and it's of course it's a challenge, right? No.
Yes, of course.
Yeah, sure.
Thank you very much, Alejandro. So are there more questions? So as I was saying before, thank you very much, Yago, for your presentation. I think it was very pedagogical, because even from people who are not experts in this field like myself, we understood the main elements of your research and how it's useful for understanding so complex data models as you show us. I wanted to make a question related with the way the users will be using your system. So you show us an example where we have a question, and later, I imagine this question was done by the user, and later the system answered this question in order to tell us what is the answer, to make relation between different data. So are you thinking of making like a discussion? So we make a sequence of questions where the system is able to give more data to the user. For example, here you say most patients with ambulatory admittance have an average waiting time between their medical surgical session. So this you are giving more not precise details, because you are talking in general terms. Imagine that the user would like to know the precise features, so the precise numbers of these most patients, about waiting time. So could the user ask the system new questions and get more detail in order to have a big overview of the model, and to try to find better the justification of these relations?
Sure. So actually, the principal idea is not to make like a discussion system, but to integrate these kind of descriptions into the existing process mining like frameworks and process mining system that exists nowadays, that are currently based only on visualization techniques. So the idea would be to integrate this to better allow the users to understand this information. In the example you see here, it's quite general, because it's simply one of the basic uses of fuzzy logic, that is like using more abstract terms like most, average, etc. But sure, with the objective or the idea is that the user can zoom or can focus its attention of any relevant aspect of the process he or she is interested in. And if instead of average waiting time, he wants to know actually the average value and its deviation, or he wants to define manually a crisp or a fuzzy interval to know, like, okay, so for me average is 35 days plus minus 2. So these descriptions we also are generating them simply I selected this case as an illustrative example, but as I told before to Alejandro, in the validation process we are taking right now, we are actually evaluating in this case study which kind of summarization experts prefer, like more abstract terms like most, average, etc. Precise values with deviations, for example, or here this is one of the deviance protoforms that we propose. That is a composition between two type 2 protoforms, but instead, if we to compose two type 2 protoforms, we would compose type 1 that instead of telling, like in this case, short waiting time, imagine it said like simply the expected value, like the expected value is 35 days, because this is a value known in the domain or known in the process or whatever. We would have that type 1 quantified statement assessing the expected value, and we would compose that with a type 2 quantified statement that would say, okay, this is the expected value, but for cases that in this case are patients, but it could be like for cars or for whatever element that has this attribute, this waiting time or this life expectancy or this quality control measure is X. So that X, that summarizer, can be as abstract or as precise as the user wants. So this is the example that I put was just like one of the many we generate now. But yes, other more precise or more particular descriptions are defined, and the granularity of the information is manually, or we want to make that can be manually or automatically in an ideal system define this granularity by the system or by the user.
Okay, so thank you very much. I think it's very interesting, the fact of always discussing with the users in order to see how the system could be useful for them. It's very important in the research. So you are doing this, so it's very nice.
Thank you.
Okay, so thank you very much. Are there more questions? Okay, it seems that not. So perhaps we can finish there.
Okay.
So, okay, I don't know if Andres has to stop recording or do something special.
Yeah, no, that will be the end of the talk. So now, thanks everyone, thanks Yago, and if there are no more questions, we can finish here whenever you want.
Okay, yeah. Thank you very much. Thank you, Antonio. Have a nice day.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye-bye.